Hi, it's Mrs. Marquette. Today we're going to talk about the last two types of factoring in the factor chapter. Get excited. And the first one is going to be factoring a sum or difference of two cubes. Now, a cube is when you have something to the third power. So x cubed is x to the third. 2 cubed is 2 to the third. So this can be numbers or variables. So it's going to be in this form, which again looks kind of like alphabet soup. But this is what you'll be given on your guide. I'm going to show you kind of a way to make this make sense, hopefully, today. And then one thing that we're going to have to be really careful about is the acronym SOAP. And what that stands for is same, opposite, always, positive. And that's going to come in when we're having our signs. So let me show you how this works. I've got here x cubed plus 8. If this is a sum or difference of two cubes, first of all, I have to know that something times itself 3 times will get me each of these terms. So x cubed is x times x times x. So yeah, that's a cube. And then I can try 8 as well. 2 times 2 times 2 is also a cube. Okay. What I want you to do at this point is circle 3 sets of pairs. Okay, we're going to do that every single time. And then I'm going to have 2 parentheses. In the first parenthesis, I'm just going to write the 2 things that are cubed. So in this case, the x was cubed, and there was a 2 that was cubed. In my second set of parentheses, I'm going to multiply what is in those pairs. So x times x is x squared. X times 2 is 2x, and 2 times 2 is 4. So what that is really doing is that is coming up with this parenthesis here, if you look at your pattern. Okay. Finally, I'm going to look at the signs. So that's where the same, opposite, always, positive comes in. I look at this original sign, and my first sign is going to be the same as that one. So in this case, the sign is positive, so same is positive. The next sign is opposite. In this case, the opposite of positive is negative. And then the last one is always positive, so that one will be positive as well. And now I have that factored. If I went through and multiplied this out, I would end up getting x cubed plus 8. If you don't believe me, try it. A lot of things will cancel out. Okay, so let's try this again. I have 125 plus x cubed. If this is a sum or difference of cubes, I will be able to write each of these terms as something times itself 3 times. 125 is 5 times 5 times 5. X cubed is x times x times x. I circle some pairs. And then when I make my 2 parentheses, in the first parenthesis is always going to be the 2 things that are cubed. Keep it in the same order, 5 and x. And then in the second parenthesis, I'm going to have 25, a 5x, and an x squared. So I now do same, opposite, always, positive. So same is going to be plus, opposite is minus, always positive. You might be wondering, can you flip the order? Yes, because it's a plus in the middle, I could say x plus 5. Here, the only thing to be careful of is you got to keep the positive or negative with the correct term. So x squared is positive, 5x is negative, and 25 is positive. I would take this either way, the top or the bottom one is fine. Next one, y cubed minus 729. If this is a sum or difference of cubes, I should be able to write each term as something times itself 3 times, so y times y times y is y cubed. 729 is 9 times 9 times 9. Double check that in your calculator if you need. 2 parentheses. In the first parenthesis, I have a y and a 9. In the second parenthesis, I'm going to circle my pairs. Y times y, y squared. Y times 9 is 9y. And 9 times 9 is 81. Look at this sign, it's different. So same, opposite, always positive. Same is now negative. Opposite is positive, and always positive is positive. So hopefully this is starting to make sense. I'm going to have you guys try number 4, and then we'll do numbers 5 and 6 together. Okay, so take a look. 6 minus x times 36 plus 6x plus x squared. Note, same, opposite, always positive refers to this minus. And you can double check and make sure everything else is good. In this case, my GCF is 4, but if I took out a GCF, I notice that I'd be left with a 4, which is also not a difference of 2 squares. So I'm going to actually take out just a common factor of 2. So I'll put a 2 on the outside, and I'm left with 8. Oh, actually, let's take a 2 and a u squared. And I'm left with 8u cubed minus 125. So now you might notice that I took that 2 out because I saw that 8 is a cube, and so is 125. So I leave the 2u squared, and then I've got a 2u, 2u, and 2u, and 5, 5, 5, and we'll circle some pairs. So now in my first parenthesis, I've got a 2u and a 5. Second parenthesis, I've got a 4u squared. 2 times 2 is 4, u times u is u squared. 2u times 5 is 10u, and then a 25. So same, opposite, always positive will give me this as my final answer. So this is the trickiest one of all of them. Strategy is you're looking for some cubes. You're looking for perfect cubes. So you might have to try some numbers, taking out a common factor before it'll work out. So just stick with it. This last one, 64a to the 4th minus 27a, I noticed that 64 is a cube. You might have to check. And 27 is as well, but a to the 4th is not a perfect cube. So the only common factor I'm going to take out of this one is an a, and I'm left with 64 a to the 3rd minus 27. Now I have perfect cubes. 64 is 4 times 4 times 4. A cubed is a times a times a. And 27 is 3 times 3 times 3. So I'll circle my pairs, and I'm left with a. And then my 2 parentheses, I'm going to have a 4a and a 3, and then 16a squared, 12a, and a 9 if I multiply those pairs. My sign is negative, so same, opposite, always positive. So that's kind of my first type. So that's our first type of factoring for today. I'm going to pause the video here and then have you guys take a look at quadratic form.